Hey guys, and welcome back. My name is Miss Danielson, and today we're looking at the congruency of triangles. Now, I know a lot of students get really confused with this topic, especially if we start in too quickly with these acronyms for the different rules for the congruency of triangles. So we're going to start right now with the very basics of these topics. Mainly, what is congruency? Two shapes are said to be congruent if they are the same shape, so for example, this black triangle here, and the same size. To be congruent, they must have all the same side lengths and angles. So, for example, this blue triangle would be congruent to the black triangle if we could measure all the side lengths and angles and confirm that they are the same. This red triangle, however, although they look like they are the same height, doesn't have the same base as the black triangle, so it's definitely not congruent. It may be a triangle, but it doesn't have all the same side lengths and angles. This green triangle as well looks like it may have the same base and even the same height, but this is a right angle triangle, and it looks like the black one and blue one might possibly be isosceles. So they're definitely not the same shape or size. Now, hopefully that was a pretty clear and simple introduction to what congruency means, but be careful because two shapes may be congruent, but not look exactly the same. We could transform shapes in some way so that they look a little bit different, but they still maintain their congruency as long as they're the same shape and size. If you're familiar with transformations, you will know that these two triangles here are congruent. One has been reflected across this diagonally sloping line, but it's still the same shape and size. The blue triangle is congruent to the gray triangle. These two triangles as well are transformations of each other. The original triangle seems to have been rotated about the point 0, 0 to form the second triangle. These rotated shapes are still the same shape and size, so they are still congruent. Finally, this last transformation represents a translation. The red triangle has simply been moved in a straight line direction 5 squares to the left and 3 squares up. The size and shape of the triangle has not changed. They are still congruent. Another bit of vocabulary that you need to be familiar with and take care not to confuse is the difference between congruent and similar. As we've said, congruent shapes are the same shape and size, whereas similar shapes follow the same proportions but are not the same size. The only transformation that does not produce a congruent image is an enlargement, because an enlargement is a proportional change of size. Let me show you an example. Here we see a light triangle which has been enlarged about the center 0, 0 with a scale factor of 2. The enlarged object is not the same size. Although it is the same shape, they're both isosceles triangles, and the angles are still the same. The side lengths are not the same. So enlarged shapes are always mathematically similar, but they are not congruent. This should be obvious when you look at two squares. We know that all squares have 90-degree angles. Both of these squares have 90-degree angles. However, this one's obviously much smaller than this one. We would never say that they are congruent to each other because they don't have the same size. But we're not talking about the congruency of squares in this lesson. We're just going to focus on triangle congruency because there are some specific rules about congruency that can only be applied to triangles. Now, we don't need to know all of the side lengths and all of the angles in a triangle in order to determine if they're congruent or not. There are 5 rules to test for congruency, and be careful because it's easy to confuse them with the 2 non-rules. First, let's have a look at how we label the sides and angles of a triangle. Here, I'm labeling all 3 sides of the triangle with S's. And now I'm labeling all 3 angles of the triangle with A's. We don't need to know all of the S's and all of the A's, but we may know some of them in some specific order. And if that order corresponds with one of the rules, then we can use that to determine if the triangles are congruent or not. Now, I know that's not going to make much sense until we get into some examples. So let's start with the simplest of the congruency rules, the SSS rule. Remember, we use S to represent a side length. So if I say 3 S's in a row, I mean that we know the side lengths of all 3 sides of a triangle. And if all 3 sides of a triangle are the same as all 3 sides of another triangle, they are congruent. For example, here I've got 2 triangles and they may not look exactly the same, but they're not to scale. And usually on exams and exercises, they are not given to scale. You just have to look at the information given. We are given all 3 side lengths of both of these triangles, and in both cases, the side lengths are 3, 7, and 9. 3, 7, and 9. So without knowing what the angles are, we don't need to know what the angles are. We know that these triangles are the same shape and size. They are congruent. Next up, AAA is not a congruency rule. I told you it could get confusing. We just need to remember that. Although you may know all angles in 2 triangles and they may match, that does not mean that the triangles are the same size. They may have the same angles, but completely different side lengths, like we saw with our square before. So if I give you an example, and again, we can't just look at them and say, are they congruent or not, because they're not to scale. However, we're given all angles in 20, 65, and 95, but without knowing what any of the side lengths are, you can see obviously in this case here, it is possible that this side length is very different from that side length. So we have no proof either for or against the congruency of these triangles because AAA is not a rule. All we can say is that these triangles are similar, but we can't prove their congruency. Our next rule is a bit more complicated because it involves both side lengths and an angle. And the order in which those side lengths and angles are given make a big difference. The SAS rule refers to 2 side lengths given along with the angle in between them. So here I've given you this side, an angle, and then this side. Or I could have given you this side and an angle and this side. The angle is between the 2 side lengths given. Or I could have given you this side, an angle, and this side. Those are all examples of me giving you SAS, a side, an angle, and a side. However, if I gave you this side, and then this angle, that wouldn't be SAS, that would be SSA. That's something completely different. Let me show you an example now. So here I've got 2 triangles, and don't try and look at them and try and decide by looking if they're congruent because they are not to scale. Don't get your ruler and protractor out, just look at the information that's given. You're given a side, an angle, and a side. In both cases, the angle that's given is between the 2 sides that are given. And the side lengths that are given are 15 and 22, and the angle that's given is 23 degrees. So in both cases, you're given the SAS, the side, angle, and side of 15 centimeters, 23 degrees, and 22 centimeters. 15 centimeters, 23 degrees, 22 centimeters. So by the SAS rule, they are congruent. These 2 triangles, however, also not to scale. Are they congruent? I've given you a side, an angle, and a side. And I've given you a side, an angle, and a side. But be careful, I didn't give you the angle in between these 2 given sides here. Here I've given you SAS, 20 centimeters, 42 degrees, and 17 centimeters. And here I gave you the side of 17 centimeters, the side of 20 centimeters, and the angle of 42 degrees. So these are not congruent. I didn't give you the same information for both triangles. Although the measurements might be the same, they are not in the same places. Our next rule, much like the SAS rule, involves both angles and sides, but this time I'm giving you two angles and the side in between. And again, I could give you any two angles with the side in between. It could be these two angles here with the side in between, these two angles here with the side in between, or these two angles here with the side in between. But remember, the placement of that side that's given in relation to the angles that are given is very important. This is not an ASA triangle. Look, I've given you an angle, and the side is not between them. This is AAS, not ASA. So let's have a careful look at this next example. Again, it's not to scale, but I seem to be given the same measurements. I've got two triangles with angles of 30 and 60 degrees and a side length of 12 millimeters. And the side length is in between the two angles in both cases. So I've got an angle side angle example here where the angle is 30 degrees, the side is 12 millimeters, and the angle is 60 degrees in both cases. So these two triangles are congruent by the ASA rule. I hope we're getting the hang of this now, but don't get cocky. Let's try another one. Be careful. Again, not to scale. Two triangles given, the same measurements given on both triangles. I've got two angles here, and I've got the side length in between. I've got a 25-degree angle, a 17 centimeter side length, and a 70-degree angle. Over here, however, did you notice? I gave you two angles and a side length which is not in between those two angles. I've got an angle of 70 degrees, I've got an angle of 25 degrees, and I've got a side length of 17, which is next to the 25-degree angle. So this is not ASA, this is AAS. So these two triangles are not congruent because they don't give the same information. This is not an example of ASA triangles. Now, it's not that AAS is not a rule. It is a rule, but the information of these two triangles does not match. AAS, or you could also say SAA, is a congruency rule. If we're given two angles and a side which is not between them, and they match for both triangles, then we know the two triangles are congruent. However, it's more complicated to decide if the information matches, because this side might be next to this angle, or it might be next to this angle, but not in between them. So it gets a bit confusing. However, we can still use the ASA rule because if we knew what these two angles were, we could always find the third angle. You should know that all three angles of a triangle add to 180, so this third angle would simply be 180 minus the sum of the other two angles. And once we know this angle, we know two angles and the side length between them. And then we can just apply the ASA rule, which hopefully will be simpler for you. If you think you can manage it, here are two triangles where I've given you two angles and a side length which is not between them. That's AAS. Are they congruent? I know what you want to say, looking at the size of them, they don't look congruent, but this is not to scale. So let's look at the given information here. I've given you two angles and a side length. This 5 centimeter side is next to the 30-degree angle. So the information I've given you is a 90-degree angle, a 30-degree angle, and a 5 centimeter side length. For the other triangle, I've also given you a 30-degree angle, a 90-degree angle, and a 5 centimeter side length. However, the 5 centimeter side length is next to the 90-degree angle. So although this is angle, angle, and side, it's in the wrong order. So these two triangles are not congruent, but I'll bet you found that a little bit complicated. So let's have a look at it another way. Even though I've got the same two angles and the same side length, let's figure out what the third angle would be so that I can look at this as an ASA triangle. If two of my angles are 30 degrees and 90 degrees in both triangles, 30 plus 90 is 120. The missing angle must be 180 minus that 120, which is 60 degrees. So here I've got a 60-degree angle, and here I've got a 60-degree angle. Now I've got two angles with the side length in between. So by angle, side angle, I've got 30 degrees, 5 centimeters, and 60 degrees for this triangle, and I've got angle, side angle, 90 degrees, 5 centimeters, and 60 degrees for this triangle. So clearly they are not the same size. They are not congruent. Although they would be similar, right? All the angles are the same. Here's another type of example. These three triangles look to be exactly the same. Be careful, they're not to scale, but it looks like they gave us the same measurements. In each case, they give us two angles and one side length. But be careful about where that side length is. Which of these two triangles are the same and which triangle is different? Well, for this first triangle, I'm given two angles and a side which is not in between them. My 20 centimeter side length is next to the 15-degree angle, not the 89-degree angle. I've got angles 89 degrees, angle 15 degrees, and side length 20 centimeters. For my second triangle, again, the side length that's given is not between the given angles. It is next to the 15-degree angle. So again, I've got angle, angle, side. My angles are 89 degrees, 15 degrees, which is next to the side length of 20 centimeters. So these two triangles seem to be congruent. This last triangle, however, is it congruent? Again, I've given two angles and a side length, but the side length is in between those two angles. Even though ASA is a rule, the information or the order of the measurements is not the same for this last triangle as it was for the previous two. Here I've got an angle of 89 degrees, a 20 centimeter length in between, and another angle of 15 degrees. So this triangle is not congruent to the rest. Not because it's not a rule, simply because the information does not match the other triangles. Now, while AAS and ASA are both rules, SSA or AS, I don't even like to say it because it's kind of an insult. It's not a congruency rule either. There are two ways that an SSA or an AS triangle could be drawn, despite having the same given measurements and in the same order. AS is not a congruency rule, and let me just demonstrate what those triangles could possibly look like. Here's an ASS triangle. I've got an angle of 20 degrees, a side length next to that of 7 centimeters, and another side length which is not next to the 20-degree angle, which is 4 centimeters. Now the trouble with this last side is I don't know where to draw it. I don't know if I should draw it at this angle or at that angle. All I know is that it should be 4 centimeters long. So I'll find all the possible points that are 4 centimeters away from this end of the line, and that gives me this arc. Now I know that my 4 centimeter line must either be off in this direction to join up with my line down here at the bottom, or off in this direction, again to join up with this line that helps make my 20-degree angle. So this could be my ASS triangle with angle 20 degrees, side length 7 centimeters, and side length 4 centimeters. Or I could draw my 4 centimeter line over here, and I could have an even bigger triangle with the same measurements. This is my 20-degree, 7 centimeter, and 4 centimeter triangle. But this here is also a 20-degree, 7 centimeter, and 4 centimeter triangle. Feel free to hit pause if your mind is being blown right now. Just make sure you hit play so we can carry on. Okay, so there are two different ASS triangles with exactly the same measurements. This is why we can't trust ASS to be a rule for congruency, because these triangles are obviously not the same shape and size. So here's another example, and it's not given to scale. However, it might be tempting to look at and say these are obviously not congruent triangles. This first triangle here has an angle of 18 degrees and two side lengths of 9 centimeters and 5 centimeters, but the 9 centimeter side length is the longest side length in this triangle. Even though it's not to scale, that's the way it looks. Whereas in this triangle, I've got the same measurements, an 18-degree angle, two side lengths, which are not on either side of the angle, one 9 centimeter side length and one 5 centimeter side length. And the 9 centimeter side length does not look like the longest side in that triangle. It looks like this is the longest side. The reason these triangles look so different, apart from the fact that they're not to scale, is that the information given is side-side angle, or angle side-side, which is as 5 centimeters, 9 centimeters, and 18 degrees, 5 centimeters, 9 centimeters, and 18 degrees. But because this is not a congruency rule, that doesn't mean they're congruent. Our last rule may look like the SSS rule. However, if there's a 90-degree angle involved, it's a right angle triangle. And right angle triangles have a special rule for congruency called the RHS rule. So although I'm tempted to look at these two triangles and say, okay, this is an ASS triangle, it's not a congruent triangle. ASS triangles are not congruent. But by definition of right angle triangles, there is always one 90-degree angle, and the longest side, which is across from the 90-degree angle, is called the hypotenuse. That's where the H comes in this rule. So our special rule that we can only use for right angle triangles, RHS, stands for a right angle, 90-degree angle, the hypotenuse, which is the 5 centimeter side, which is across from the 90-degree angle, and any side length. It doesn't matter which one because it will be next to the 90-degree angle regardless. And I have that the same in both cases as 4. So here, by the RHS rule, the right angle, the hypotenuse, which is across from it, and another side length that's given, these two triangles are congruent. If you want to pause to get that information down, our last rule, the RHS rule, applies only to right angle triangles where you've got the right angle, the hypotenuse side, which is across from the right angle, and either of the other two sides. It doesn't matter which one. One last example before we get into the practice. Here I've got two triangles and I know how tempting it is to just look at them and say, okay, they're congruent because they look congruent, but let's look at this carefully. I think they look congruent. They look the same. They've clearly got a common angle and two common side lengths. But it looks like this is ASS. I've got an angle of 90 degrees, a side length of 34 centimeters, and a side length of 42 centimeters. And even though I have the same information for both of these triangles, ASS, AS is an insult, it's not a rule. However, pay attention to the angle that we're given. It's a 90-degree angle. It's a right angle. So I'm thinking maybe it's RHS. I've got a right angle, a 90-degree angle on both triangles. I've got an hypotenuse, that's the side length, that's the longest side length across from the right angle. It's 42 centimeters in both cases. And I've got another side length, and it doesn't matter which one it is. The other side length is 34 centimeters in both cases. So by RHS, not by ASS, but by RHS, these two triangles have a right angle, common hypotenuse, common side. They're congruent. To sum up our congruency rules now, make sure you've written these down and you don't get them confused. There's the SSS rule. If all sides for both triangles match, they're congruent. The SAS rule, if you've got two sides and an angle in between them for both triangles, which are the same, they're congruent. Again, if I got two angles and a side in between for both triangles and they're the same, they're congruent. These ones are the easier ones to check for. A harder one might be angle, angle, side, or side, angle, angle. And remember, in this case, if you know two angles, use the fact that the sum of the angles add to 180 to find the third angle. And then you can use the ASA rule. If they match, they're they're congruent. And finally, if you see a right angle triangle, look for the right angle hypotenuse side rule. If you've got the right angle, the longest side which is across from it, and either of the sides, and they match for both triangles, they're congruent. You could also have a right angle and two sides, where the right angle would be in between the two sides. That would be SAS. So that would also be congruent. So right angle triangles are ones we like to see. We get more information there than you might realize. 5 rules and 2 non-rules. AAA triangles are not congruent. They may be similar, but they are not necessarily the same size. And of course, as is an insult, it's not a congruent triangle. ASS is not a congruency rule. Now that you've got all of that down, let's go on to some practice exercises. Find the pair of congruent shapes. Now these are not all triangles, but find the pair that are the same shape and the same size. For question 2, there are 7 triangles there, and these are to scale because I've used this centimeter square paper. Find the triangles which are the same shape and same size. Go ahead and hit pause if you need a minute, and hit play when you're ready to take that up. Here come your answers. For question number 1, these 2 rhombuses or rhombi are congruent. All the other shapes are different shapes and different sizes. For question 2, these 2 triangles are the same shape. They're both right angle triangles and the same size. If you look at the perpendicular sides, this is 2 squares and this is 3 squares. This is 2 squares and this is 3 squares. They may not have the same orientation. It looks like maybe one triangle has been rotated to form the other, but they are congruent. Hopefully questions 1 and 2 were pretty easy. Let's go on to level 2 of our practice now. For each of these pairs of congruent triangles, identify the congruency rule. Now I know they're congruent. I'm telling you they're congruent. Don't tell me that they are congruent. Tell me what rule proves that they are congruent. Go ahead and hit pause now so you can have a think about that, and hit play when you're ready to take up the answers with me. I hope you had a chance to hit pause, because here come our answers. For part A, this is the SAS rule. I've got 2 sides and the angle in between them. For question B, I'm given all 3 sides of both of these triangles. That's the SSS rule. For question C, I'm given 2 angles and 1 side length, but be careful because the side length is not between the 2 angles. The side length that's given is next to the 25-degree angle. That's angle, angle, side. Alternately, if you're like me and you find the angle, angle, side rule a bit complicated because you don't know where the side belongs, is it next to the 80-degree angle or next to the 25-degree angle? You may have used the angle, side, angle rule. That is by finding the third angle. If these 2 angles are 80 degrees and 25 degrees, 80 plus 25, that makes 105. The last angle must be 75 degrees in both cases. So we've got angles of 75 degrees, sides of 10 centimeters, and angles of 25 degrees in both cases. I hope you guys found these level 2 questions a little bit more challenging. We wouldn't want you getting bored, but let's try something even more challenging now. On to level 3. Prove and explain your answers in words. Don't just tell me that they're congruent. Explain to me how you figured it out. Question 4 is a parallelogram made up of 2 triangles. A, B, D is one triangle, and B, C, D is another triangle. Prove that they're congruent and explain how you've proven it. And question 5 has a diagram where the lines CE and DF, so CE and DF, intersect, they cross at this point G here. CD and FE, that's this line here, and this line here, are parallel, marked with these red arrows, and equal. Prove that triangles CDG, that's this one here, CDG, is congruent with triangle EFG, the one down here. Go ahead and hit pause. You're going to have to take a minute with this and look carefully at all the hints and all the clues that could help to prove that these are congruent. Hit pause now and hit play when you're ready to take it up. I really hope you hit pause. Don't just wait for me to tell you the answers. Here they come though. For question 4, we know this is a parallelogram. So that means that we know side lengths BC and AD are parallel to each other. And if you know about parallel lines, there's a set of rules that explain the angles that are formed between parallel lines and a line that crosses through them. As we can see here, we formed a Z pattern. And the angles in a Z pattern are called the alternate angles. They're equal to each other. So we know that we've got a pair of equal angles, even though we don't know what they are. We also know, because these are parallelograms, the opposite side lengths are equal in length. So BC is the same length as AD, and AB is the same length as DC. So I know a lot about this parallelogram and these two triangles without actually knowing any actual measurements. I know that they've got a red side equal to each other, a blue side equal to each other, and this yellow side, which they share, is obviously equal for both of them. So by side, 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 these two triangles are congruent. Also, since we've got these angles which are equal to each other, I've got the yellow side, the green angle, and the red side in triangle ABD. And I've got the yellow side, the green angle, and the red side in triangle BCD. So they're congruent as well by side, angle, side. There's two ways I can prove it. On to question 5. We know, first of all, that side length CD and FE are equal. That might come in handy. Also, we know that any two crossing lines have opposite angles which are equal to each other. So the angle CGD is equal to the angle FGE. And by parallel line theory, we could see some alternate angles here. I can make a Z pattern again with this parallel line and this transversal here, forming an alternate angle at D and at F. I could also draw a Z pattern with this transversal here. The line from C to E makes an alternate angle here at E and an alternate angle here at C. So those are also equal to each other. Now looking at this information, it looks like I've just got 3 angles in the top triangle and 3 angles in the bottom triangle, which are equal. The yellow ones are equal to each other, the blues are equal to each other, and the greens are equal to each other. But be careful, because A is not a congruency rule. However, remember what we said at the beginning? CD and FE are equal to each other. So not only do I have all 3 angles, I've also got a side length. Without actually knowing any measurements, I can compare these two triangles and say they've got an angle, and side in common, so yellow, blue, and red, yellow, blue, and red. Or they've got a side, angle in common. They've got the red, they've got the green and the yellow, red, green, and yellow. Or I find this the easiest one, where the side is in between the angles. I've got the blue angle, the red side, and the green angle. I've got the blue angle, the red side, and the green angle. 3 different ways I could have proven that one. Did you manage? If so, well done. If not, take a minute to look this over, because these are quite common questions here. No measurements were given, but we know our rules about angles, so we can prove congruency by our congruency rules. Now that's it for our practice questions, but here's a bonus challenge for anybody who feels up to it. I am not going to give you the answer on this one because I want to see who can think it through, and I want you to take the time to think it through for yourself. Here we've got two squares. We're not given any side lengths or angles, but we're told that they are both squares, so think about what you know about squares. Use congruent triangles to prove that length dk is the same as length fm. So look for some congruent triangles there. We should know they are congruent, and if we know they are congruent, we know that these side lengths must be exactly the same size. If you need a hint, here you go. This is dk and this is fm. All four sides of any square have the same length. Keep in mind as well, regardless of the size of the square, all of the angles are 90-degree angles. Good luck. I hope you found this lesson interesting and helpful, and I hope I really caught your interest in this last challenging question here. Leave a comment down in the comment section if you want any help, or if you think you've got it and you just want to show off a little bit. You've earned it. Anyways, till next time, keep practicing and have fun.